Hello and welcome back to the second in this series where we'll together be learning Prolog. In the first video previously, we just dipped our toes into the most basic Prolog we could do, and that was to create simple facts and query them and testing them to see if they were true or false. We had this idea of building a database of facts and constructing queries which essentially ask Prolog, is this true or false? So we're going to just take that a little bit further today and introduce the idea of variables. So on the screen you can see, if I zoom in a little bit, a very short Prolog program which should be familiar from last time. We can see there's a comment. This is telling us example 2, and remember Prolog ignores comments. They're for us to read. Here's another comment about telling us that this next bit of code will be about red fruit. We have this concept of things and properties. So here the things are apple, cherry and grape, and they all have a property called red. And you might remember if we asked red apple as a query, that's asking Prolog, is this true? Yep, so we can test if apple is red. We can test if cherry is red. And we can ask if grape is red. And they should all come back as true because the Prolog program, which constructs what is true about this kind of universe that Prolog lives in. So just to test and refresh ourselves, if we said mango, we expect Prolog to say nope. And the reason it says nope is not because it knows that mangoes aren't red. It's saying that it can't prove that a mango is red. Just again, remind of that difference. So it can't prove that mango is red. And the reason it can't prove it is because there's nothing in the database of facts that tell Prolog that this is true. Right, so let's introduce a new thing. If we say red X, and I'm using a capital letter here, what do we think this is going to do? So again, I'm encouraging us to think before we kind of zoom ahead and type all the code and click run, because thinking about it actually helps us understand and get closer to how Prolog actually works, and that's how we use it effectively, by understanding what's happening inside. So let's deconstruct this. We've created a query and we're asking whether a thing called X is red, just like we did here. A thing called apple is red. That's the query. A thing called cherry is red. That's the query. A thing called X is red. And that's a good start. That's a good way to start thinking about it. But there's a difference, which is why we're doing this session today. The difference is that things that have a capital letter at the start, like X or fruit with a capital F, those are called variables. Think of it as a label or a name that hasn't been associated with a value yet. So fruit is like an empty box, or X is an empty box, and it hasn't yet had a value associated with it, and it's eager for that to happen. So what we're actually asking is, what X can make red true? That's what we're asking. That's easy to understand, isn't it? We're saying, which X makes red X true? And again, before we run the code, we can look through the database here, and we can say, well, if X was apple, would that be true? Red apple, yep, we know that's true. Does cherry, if X is cherry, so this isn't valid Prolog, but if I said X equals cherry, would that make the statement true? And the answer is yes. What about if X was mango? Well, that wouldn't be true. So that's what these variables can be used for. They can be used to ask Prolog, rather than asking specifically, is apple red, is cherry red, is grape red, what we're doing now is asking which things make this statement true. And that's so important, I'm going to write it. So red, that's a property, variable x, that's a question, full stop. This is the standard form for a query in Prolog. We have a question mark and a dash, and in this website it's done for us, so it just makes it easier. It's just an old historic thing, so just so you recognize that there when you look at other textbooks. And it's saying which x makes the statement true. That's what the variable in this context does. So that's an important concept to kind of grasp, and let's run the code to see how that works in action. So if I run the query, it's telling us, ooh, x equals apple works. Great. But it's asking us if we want to continue next. It's suggesting there's more answers. So we know that x equals apple will make this true. Let's click next. X is cherry. It's found another answer that makes this statement true. It's got another one. Next. Grape. So when x equals grape, this is true. But now it's not offering any more potential solutions. It's not asking to continue searching for more answers. So let's slow down and pause there, because an important thing has happened. So Prolog has taken this query with a variable, and remember, by putting a variable in a query, we're asking Prolog which things would make it true. You know, which values of x would make that query true. And Prolog has gone away and found an answer, x equals apple, and that's correct. When x equals apple, we know that red apple is true. But it also continued to search for other solutions. X equals cherry was offered as a solution. We know that when red cherry, we know that's true. And it continued with another one, grape. So that's important, that idea of Prolog trying to find as many answers as it can to a query. Because clearly, if we step back and think about it, red X does have more than one answer. It's like some of those mathematics kind of equations where more than one value of X can satisfy the equation. You know, quadratic will have two solutions sometimes. So here, X, there are three values of X which would work. So that's the important thing there to kind of take away is when we introduce variables, we're asking Prolog to fill in or try to fill in the value of that variable. And the second important thing to take away is Prolog's engine will try and find more than one answer, as many answers as it can, and that's good for us. That, you know, that we take advantage of that. I'm just going to show you a picture. By the way, this is a blog that will, there'll be a write-up for all of these videos if you want to read in slower time, or more carefully constructed text than my talking what's happening. So that's this example. And these things, these pictures, you'll see them in some of the textbooks, and they might be called search trees or sort of resolution trees. And essentially what they're showing is the query and how Prolog works. So we've got a query, red X, and Prolog will look in the database and find red apple. So x equals apple is an answer that it can give. And then it doesn't stop there. It goes back up to red x, as in it unsets the value of x. So x is apple here, but it goes back to the point where x does not have a value. And it looks in the database again and finds a red cherry. And so x equals cherry is a valid answer. And then it continues, it unsets x, so it's empty again. Goes back and looks in the database and finds a red grape. So x equals grape is an answer. And then it goes back to unset x, and this time there's nothing else in the database to look at. Remember, we only had 3 facts, so that's the end of the query, and there's nothing more to be found. This is called backtracking, this going back. So we start off with x not being set, we look through the database, and we try x equals apple, and that works, and then we go back and then try again, something else, go back. So that's called backtracking. We're just introducing that term, backtracking. Don't worry if it feels too jargony. We'll come back to that idea properly a few times in future videos. But I just wanted to kind of share what was happening there. Now, you might ask, well, why doesn't Prolog try mango or avocado or cat or dog or aeroplane or window or grapes? Well, grape is here but not grapes. There are lots of things it could try to see if x equals that thing would work. So x equals avocado, x equals banana, x equals car, x equals fish. It doesn't try all those. It could, but that's not how it works. That would be a very inefficient way of trying to find solutions for x. Let's draw a picture. So this is the database. We've got red apple, red cherry, red grape, and the query is red x. Could have been y, could have been fruit, as long as there's a capital letter at the start to indicate that it's a variable. Now, we were just asking ourselves, why doesn't it try x equals avocado, or x equals fish, or x equals Mars, or x equals Jupiter, and so on. Lots of things it could try to see if they were true, but it doesn't do that. And that's because that would be very inefficient, just randomly trying different values. It's a way, and if you had infinite time and access to infinite potential values, that might work. But a more efficient method is to, well, let's start from the position that everything that can be true is in the database. So let's look in the database, and you can see almost straight away that there's a correspondence between red, 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 and x matching these things. So that's how Prolog works. It takes the query red, x, and then takes something in the database like red apple, and it tries to match them. And the matching happens by comparing the property, red and red, and the variable and the thing. So red matches red, tick. X matches apple. Because x is a variable, it's empty, so it can match anything. So it will match apple, tick. So that works. If our query was hairy x, then that would not match anything in the database because there's no property in the database mentioning hairy, so that would never match. So this idea of matching, we'll come back to it, and it's called unification, and it's an important mechanism in Prolog. So this is our first taste of it. So we've talked a lot, so let's step back there and just repeat what we've just learned. To find variables, to find values for a variable, Prolog doesn't randomly try values. It tries to match the query with facts in the database, and that matching has two parts. It matches a property and then the content, the thing inside the brackets, and that's called unification. Unification, if I can spell. And here's just on the blog you'll see just some examples of unification, when it works and when it doesn't. And you can see the matching. So if the query is tasty apple and the fact in the database is tasty apple, that unifies because the property and the thing matches. Tasty apple with tasty banana doesn't match because the property might match but the thing inside doesn't. If we have a query tasty apple and a fact called red apple, again that doesn't match because the properties here are different. So both the property and the thing inside the brackets, has to match. Now we introduce the idea of variables. So tasty x, a variable is empty, so it will match anything. So if we have a query tasty x, can it match, can it unify with a fact in the database which is tasty apple? And that does, and it leaves x equal apple. Again, we'll come back to this, but that's how Prolog finds answers. Starts off with not knowing what x is, looks in the database and finds a fact called tasty apple. Tasty matches tasty, x matches apple, so it says yep, that matches as long as x equals apple, and that's how it finds a solution. Just to complete the examples, to give a counterexample almost, tasty x won't unify, won't match with red apple. So even though x could become apple, the properties don't match. Tasty can't be red, so that doesn't. So that's kind of worth looking through those. Again, if you want to do this afterwards, just kind of go to the blog and have a look at that. So we've covered a lot today. Just in our second video. We seem to have jumped from last video where we did the most simplest thing, which was just to create facts and query them. Today we've introduced variables. We've talked a little bit about how Prolog goes about finding answers for those variables, and we've introduced the idea of unification. So we'll stop there. That's quite a lot to take in. Have a play yourselves. All the code is on GitHub online. Read up afterwards if you want on the blog, and we'll continue next time. See you soon. Bye.